Usually, when you pull up a map on your phone, there's this underlying expectation of, like, absolute authority,
Yeah, for sure.
like gravity, you know?
Mm.
You type in the name of a coffee shop, a blue line appears on a perfectly rendered grid, and you just blindly follow it.
Right. I mean, it feels algorithmic, doesn't it?
Totally.
We just sort of assume there's some giant satellite or, I don't know, a room full of corporate engineers in a windowless bunker somewhere, just handing down the absolute definitive truth of the physical world.
Exactly.
Huh.
But when you actually peel back the layers of how geospatial data comes together, that omniscient satellite is replaced by something completely different.
Yeah, it really is.
It is messy, it is deeply human, and it is entirely crowdsourced.
Mm-hmm.
And that is our mission for this deep dive. We are unpacking the hidden engine behind the maps you use every single day, whether you realize it or not.
It's a fascinating topic.
It really is. We are pulling from a great stack of official documentation today, specifically from LearnOSM, the OpenStreetMap Foundation, and OpenStreetMap US.
Yep, the primary sources.
Okay, let's unpack this. OpenStreetMap isn't just a navigation app on your home screen. It is this massive, free, editable geographic database of the entire planet.
Right. Think of it as the Wikipedia of maps.
Ooh, I like that comparison.
Yeah, and much like Wikipedia, to truly grasp how this global map is built, you first have to understand the paradox of who actually owns it.
Right.
Because maintaining a living, breathing digital replica of the Earth, I mean, that requires massive resources.
Of course.
Someone has to pay for the servers that hold all this data, right? Someone has to hold the legal trademarks.
Which brings us to the OpenStreetMap Foundation, or the OSMF.
Exactly.
They are an international not-for-profit organization built to support the project. But looking at their charter, they operate under this really fascinating philosophy regarding control.
They really do. It's unique.
Yeah, they pay the bills, they manage the infrastructure, but they explicitly do not control the map data itself.
Right.
Like, they refuse to dictate what the community maps or how they map it.
Yeah, their mission is purely about encouraging the growth and distribution of free geospatial data. And if you look at their membership structure, it perfectly reflects that ethos.
Oh, right, the fee structure.
Yeah. Joining the foundation costs £15 a year.
Got it.
However, that fee is completely waived if you are an active OpenStreetMap contributor.
Wow.
Yeah, they are placing a direct, tangible value on your sweat equity.
That's incredible.
I know, right? Your time spent mapping the world is considered just as valuable, if not more so, than a financial donation.
So the OSMF is basically like a city's parks department.
Okay, yeah.
Like, they make sure the grass is cut, the sprinkler systems are running, and the gates are unlocked every morning.
Mm-hmm.
But they don't tell you how to play your game of Frisbee once you walk inside.
That is a perfect way to put it.
But honestly, I have to ask, if they just mow the grass and walk away, how does anything actually get mapped?
What do you mean?
I mean, how do you map a whole planet without a boss assigning territories or, like, setting quotas? It seems like it would just devolve into chaos.
I get that.
Sure.
But that perceived chaos is actually a highly structured decentralization. And really, it's the secret to their scale.
Okay, how so?
Well, by removing top-down corporate control, the foundation basically forces the community to take ownership.
Interesting.
Yeah, the OSMF relies on these specialized working groups to handle the friction of running a global project.
Like, what kind of friction?
So you have an operations working group keeping the servers online.
Yeah.
You have a licensing working group navigating the incredibly complex legal realities of open data across different countries.
Oh, right. The legal stuff would be a nightmare.
Exactly. So by absorbing all that administrative and legal burden, the foundation clears the runway.
Gotcha.
The mappers don't have to worry about server uptime or getting sued. They just have to map.
That structural separation makes a lot of sense. It isolates the bureaucracy from the cartography.
Precisely.
But that still leaves the physical act of drawing the map.
Right.
You don't just wake up one day inherently knowing how to digitize the global road network.
No, definitely not.
If you, the listener, want to add a new hiking trail or maybe a local business to the map, you need an on-ramp.
And that on-ramp is an entirely separate ecosystem called LearnOSM.
Yes, LearnOSM.
It functions as this comprehensive training ground. It takes volunteers from absolute beginners to advanced spatial analysts.
Reading through the LearnOSM documentation was quite an experience for me.
Yeah.
Yeah, because it feels less like reading a textbook and more like a tutorial for a video game.
That's so true.
For beginners, they introduced something called the ID editor. And it's completely browser-based.
No downloads required.
Exactly. You don't install heavy software. You just create an account, open your browser, and suddenly you're looking at a high-resolution satellite photograph of your own neighborhood.
And the interface is incredibly intuitive.
It really is.
You just, you select a shape, say a rectangle, and you literally click on the corners of a rooftop you see in the satellite image.
Just trace it.
Right, trace it, and then you tag it. You tell the database, this polygon I just drew is a residential building, or this line is a secondary road.
Here's where it gets really interesting.
Oh, yeah.
The documentation actually gives you architectural strategies. Like, it teaches you how to trace rectangular buildings versus how to trace round buildings. It shows you how to align aerial imagery if the satellite photo is slightly distorted by the angle of the camera.
It's super detailed.
It's like playing a giant game of SimCity. You're making the digital world match the physical one polygon at a time.
And every time you finish an area, you save your work with what they call a change set comment.
Right.
Basically explaining what you altered so the rest of the community understands your edits.
But it doesn't stop at the browser, right?
No, not at all. Once you master that ID editor, LearnOSM provides a pathway to more complex tools for users who want to manipulate massive data sets.
The heavy-duty stuff.
Yeah.
Yeah.
They introduce GeoSM, the Java OpenStreetMap editor.
Right, GeoEdM.
This is a desktop application used by the power mappers. It allows for offline editing and utilizes complex plugins to ensure things like topological accuracy before uploading massive changes back to the global database.
Wait, time out. Topological accuracy.
Yeah.
For those of us who aren't cartographers or software engineers, what does that actually mean? Are we just making sure the roads connect?
It's a bit more nuanced than that.
Okay, unpack that.
Think about how a human looks at a map versus how a routing algorithm looks at a map.
Okay.
If you draw a highway crossing over a river, a human understands that it's a bridge, right?
Right, obviously.
But if the digital lines intersect on the same two-dimensional plane without the proper topological tags,
Oh, I see where this is going.
yeah, a GPS routing algorithm might think there is an intersection there. And it'll tell a driver to take a left turn off the bridge and directly into the river.
Wow. Okay, yeah, that's bad.
Very bad. So topological accuracy ensures that the logical relationships between spatial features, like what connects to what goes over or under what, are flawlessly coded.
Got it.
And GeoSM provides the rigorous tools to manage those relationships.
That makes perfect sense. The lines aren't just a picture, they are a set of physical rules.
Exactly.
And understanding those rules becomes absolutely critical when we look at one of the most powerful applications detailed in the LearnOSM sources, humanitarian mapping.
Oh, yeah. This is huge.
They feature official training materials from TeachOSM, the humanitarian OpenStreetMap team.
This is really where crowdsourced cartography saves lives.
Truly.
When a natural disaster strikes like an earthquake, a tsunami, a massive flood, first responders need immediate granular maps to understand where roads are blocked, which bridges are down, and where populations might be stranded.
Right, and they can't just use standard commercial maps for that.
Exactly. Commercial maps often don't have detailed data for remote areas, and they certainly don't update in real time during a crisis.
So to solve this, LearnOSM teaches volunteers how to use a tool called the Tasking Manager.
Such a brilliant system.
It's amazing. Let's say a hurricane hits an island. The organizers draw a digital box over the affected area.
Right.
And then the Tasking Manager software chops that massive box up into hundreds of tiny little grid squares. You could be sitting in your living room in Chicago, hundreds of miles away. You log in, claim one specific tiny square, and the system feeds you the freshest satellite imagery of that exact spot, taken just hours after the storm.
And then you compare that fresh imagery to the existing map data.
Right.
You might see that a vital supply road is now buried under a landslide.
Wow.
So you edit the line, tag it as impassable, hit save, and release your grid square back to the system.
But wait, how does your edit in Chicago actually reach a rescue worker in the disaster zone?
Good question.
Because if a hurricane just wiped out the power grid, they aren't exactly refreshing a web browser on their phones, right?
No, definitely not.
Yeah.
That is where the raw data extracts come in. The sources highlight tools like GeoFabric and HOT export.
GeoFabric, right.
These platforms allow geographic information system professionals, like the data scientists working with the rescue teams, to constantly pull the raw, updated OpenStreetMap data and convert it into specialized file formats.
I see.
They can take the changes you just made in Chicago, package them into an offline routing file, and load them directly onto a first responder's handheld GPS device.
That is just incredible.
It really bridges the gap between thousands of global volunteers and a single rescue worker navigating offline in the field.
And LearnOSM doesn't even stop at desktop editing.
Nope.
They have entire chapters devoted to mobile mapping. They outline how to use smartphone apps, physical GPS trackers, and a feature called OSM Notes.
Oh, OSM notes are great.
Yeah. If you were just like walking your dog and you notice a new stop sign that isn't on the map, you don't have to draw it right then.
Right, you might not have the time.
Exactly. You just drop an OSM note, basically a digital pin with a comment, so another mapper can verify it and update the database later.
It illustrates the incredible scalability of the project, doesn't it?
It really is.
The exact same foundational tools empower a casual observer to log a stop sign and also coordinate thousands of global volunteers during a humanitarian crisis.
Okay, so we have this massive global server infrastructure managed by the foundation, and we have the LearnOSM ecosystem teaching people to trace rooftops and manage topological data.
Right.
But drawing a map of a rural village in a crisis requires entirely different cultural and geographical knowledge than, say, mapping downtown Manhattan.
Oh, absolutely.
So how does a single global data set handle those hyper-local nuances?
Well, to understand that translation from global data to local culture, the source materials guide us to look at regional chapters, specifically OpenStreetMap US.
Right, OSM US.
OSM US is a nonprofit dedicated to supporting the project within the United States, and their operating philosophy provides a great answer to your question.
Which is?
Their motto is, "We don't just build maps, we build mappers."
I love that. And looking at their community projects that focus on the mappers themselves really shines through.
It really does.
They take this massive, intimidating global database and turn it into highly specific, localized actions. One of my favorite examples from their charter projects is Map Roulette.
Oh, Map Roulette is so cool.
We describe it as the game of mini-mapping challenges.
It's a brilliant exercise in gamification.
How does it work exactly?
Instead of opening a map of your entire state and just feeling paralyzed by the sheer volume of missing data, Map Roulette feeds you one microscopic task.
Okay.
An algorithm might spot a road that doesn't quite connect to another road. It isolates that specific error, drops you right at that location in your browser, and says, "Can you fix this one connection?"
Oh, that's so satisfying.
Right. You fix it, spin the digital wheel, and it hands you the next micro task.
It breaks an impossibly large project into, like, a slot machine of productivity.
Exactly.
Another project that really stood out is Open Historical Map.
Yeah.
They actually embraced the tagline, "Building the world's most out-of-date map."
Which is hilarious.
It is.
Yes.
They're using the exact same infrastructure, the same servers, and the same editing tools.
Right.
But instead of mapping the present, they are mapping the past.
It transforms the database into a crowdsourced historical atlas.
Wow.
Users trace old railway lines that were torn up decades ago, or they map the shifting borders of cities over centuries. It basically uses spatial data to tell the story of how a place evolved.
Then there is the Americana project.
Oh, the Americana style.
Yeah, because remember, the data sitting on the OSM servers doesn't actually have a visual style.
Right. It's just raw code and tags.
Exactly.
Yeah.
How it looks, the colors of the parks, the thickness of the highways, the fonts, that's all determined by a rendering engine. Americana takes that raw open data and intentionally styles it to look exactly like those classic fold-out paper highway maps you would buy at a gas station on Route 66 in the 1970s.
It's so nostalgic. By applying that custom visual style, the Americana project proves that open data can reflect a very specific local identity.
Right.
The underlying data is universal, but the presentation taps into American cultural nostalgia.
But OSM US doesn't just focus on digital interfaces. They have a project called Field Papers, which honestly might be the most fascinating workflow in the entire stack.
It's so creative.
It is a completely pen and paper mapping system.
Wild, right?
Let's say you want to map a local park, but you don't want to stare at a phone. You go to the Field Papers website, select the park, and print out a physical paper map.
Just a normal piece of paper.
Right, but the system prints it with a unique QR code in the corner.
Ah, the secret ingredient.
Yeah, you put that paper on a clipboard, walk around the park, and literally draw in the new benches or walking paths with a pen.
And here's the mechanical genius of that system. When you get home, you take a photo of your hand-drawn map with your phone and upload it. The Field Paper server reads that QR code, understands exactly where on Earth that piece of paper represents, and perfectly aligns your scribbles over the digital map in your editor.
That is so cool.
It is. You then just digitally trace over your own handwriting. It bridges the analog and digital divide, which is incredibly practical for educators taking students out into the field without, expensive tablets.
Which feeds directly into another OSM US initiative, TeachOSM.
Right.
A program dedicated to bringing these mapping tools into classrooms to teach students spatial literacy.
It's a great initiative.
But looking at all of these community projects, from students using field papers to people playing map roulette, I have to challenge the premise here for a second.
Okay, lay it on me.
If literally anyone with a web browser can edit the map, and map roulette turns it into a game, what stops someone from writing a bot that draws a fictional 50-lane highway right through the middle of Central Park?
A vandalism question.
Yeah. Doesn't this radical openness make the map fundamentally vulnerable to vandalism, or just sheer incompetence?
It is the most common and honestly vital skepticism leveled at open source systems.
Because it seems so fragile.
Right. The assumption is that open access guarantees lawlessness. But the OpenStreetMap ecosystem survives because it has a robust digital immune system.
Digital immune system.
Yeah. The OSM US documentation points directly to a tool called OSMchar.
Ah, the OpenStreetMap change set analyzer.
Exactly. OSMchar is this immensely powerful validation tool built specifically to track anomalies.
How does it work?
Every time someone hits save on the map, it generates a change set. OSMchar monitors the global feed of these change sets in real time.
Okay.
If a brand new account suddenly deletes 5,000 buildings in 5 minutes, OSMchar spots the anomaly. It flags that change set like an antibody responding to a virus.
So the experienced mappers aren't just blindly trusting the data, they are monitoring a dashboard of flagged activity.
They are. A veteran mapper can review that flagged change set, see the vandalism, and with a single click, completely revert the damage, restoring the map to its previous state.
That's reassuring.
And this concept of validation is baked into every level of the project. Going back to the LearnOSM tasking manager we discussed earlier.
With the hurricane response.
Right. When a volunteer finishes their grid square during a hurricane response, that square isn't immediately trusted. An experienced validator has to review the work. They check the topological accuracy, they ensure the tags are correct, and only then is it pushed to the raw data extracts.
I see.
The gamified inputs of newer users are constantly balanced by a rigorous, systematic review from the veterans.
So it is a system built on trust, but heavily fortified by verification.
Exactly.
And clearly, this system of consensus works, because this data isn't just a hobbyist experiment. It is trusted by the largest professional organizations on the planet.
Oh, absolutely.
The OSM US sources actually highlight an event scheduled for May 6, 2026. They are hosting a virtual Mappy Hour in collaboration with ESRI.
Now, ESRI is the industry titan in professional geographic information systems.
Right.
The fact that they are collaborating with a crowdsourced volunteer organization speaks volumes about the quality of the data.
It really does. And the title of the event is brilliant. I'm already using OpenStreetMap.
So fitting.
Because the goal is to demonstrate exactly how the world's largest collaborative map is already powering the logistics networks, the weather apps, and the infrastructure tools that professionals and everyday people rely on without even knowing it.
The ubiquity of the map is practically invisible.
Yeah.
But once you know it's there, you see it everywhere.
So let's pull all of these threads together. We started with the OpenStreetMap Foundation, understanding how they absorb the financial and legal friction so the community can actually map. We waded through the LearnOSM training ecosystem, discovering how a volunteer goes from tracing a rooftop in a browser to feeding offline routing data to a first responder in a disaster zone.
Yeah.
And finally, we looked at how OpenStreetMap US localizes that global data, turning it into historical archives, paper workflows, and gamified challenges, all protected by the digital immune system of OSMchar.
It is truly a masterclass in how decentralized communities can build infrastructure that rivals and often surpasses proprietary corporate systems.
So what does this all mean for you?
Well, for you, the listener, it means your relationship with that little blue dot on your screen should fundamentally change.
How so?
The next time you open an app to check a route or find a trailhead, realize that the path you were looking at is not the omniscient product of a satellite in a windowless bunker.
Right.
It is the result of human consensus. That subtle curve in the road was likely traced by a teenager playing map roulette, verified by an engineer using OSM CHA, and hosted on servers paid for by volunteers.
Wow.
You aren't trusting a corporation, you are trusting a community that simply cared enough about their corner of the world to put it on the map.
It breathes life into the digital grid. It makes the map human.
It absolutely does. And I would leave you with one final thought to mull over, building on the concept of that Open Historical Map project. For centuries, cartography was exclusively the domain of empires. Kings, governments, and massive corporations drew the maps, and therefore they defined what was important.
They decided what existed.
Exactly. They decided what existed and what was ignored. But today, the infrastructure exists for communities to map their own realities.
Right.
If a neighborhood can log its own present and even reconstruct its own past through crowdsourced historical tracing, how might that fundamentally change who gets to define history in the future?
That is a fascinating question.
Do we ever truly understand the reality of a place until we see what its own residents choose to put on the map?
Who draws the lines, holds the power,
Yeah.
and suddenly millions of people are holding the pen.
Exactly.
It totally shatters the illusion of that blue line handed down from above. You're following a path carved out by an entire ecosystem working together.
Yeah.
Well, thank you so much for joining us on this deep dive.
My pleasure.
And to you listening, we will catch you next time.